Today we are going to talk about the first lesson in algebra, which is the set of rational numbers. Before starting my lesson, we must make review in the previous sets we have studied before, like the set of natural numbers, which is open braces, first element 0, 1, 2, 3, and so on. And also we have studied before the set of integer numbers, which is abbreviated as capital Z, equals, at the middle here it will be 0, and the right side will be 1, 2, and so on. To the left side it will be -1, -2, and so on. Today, what about the new set rational numbers? The set of rational numbers, to write it, we must know its definition, which is the set of rational numbers is any number can be written in form of A over B. What is the meaning in form A over B? I mean here fraction 4. Any number we can put it in fraction 4 is called rational number. But there are one condition here. The denominator here must be not equal 0. Like these numbers. All of this number is called rational number. How? Because here we have 9 here, its whole number. We can put under 9, 1. It will be in form A over B. So 9 over 1, it will be equal 9. Both of them are rational numbers. The same with 0, the same with -3. We can put its denominator over 1. 4.5 by using your calculator, it means 9 over 2, okay, or 45 over 10, the same. So we can change into fraction form. So this decimal number is called also rational number. The same with -0.5. And here 1 and 4 or 5, this is a mixed number. By using your calculator or using your steps, we can change from mixed number into fraction 4. How? By multiplying 1 by 5, it will be 5. 5 plus 4, it will be 9 over 5. This is also rational number. The same 25%. By using your calculator, it means quarter, or we can put it in the fraction form, it means 25 over 100. The same, 5 minus 5, it will be 0 over 6. 0 over 6 here is a rational number, 0 over 7 is a rational number. But in this case, 7 over 0 or 9 over 0 or any number over 0 are not rational numbers. Why? Because I told you before in this definition, it will be fraction, but the denominator here must be not equal 0. Okay? Okay. And we know that set of natural numbers, subset of set Z, and set Z subset from set Q, which is the set of rational numbers. Set of rational numbers abbreviated as capital Q. And we note here also any natural and integer number is a rational number. As we have studied before, any natural and integer is considering rational number. But not all rational numbers is an integer or natural. How? Like that. This exercise we can change. This is rational number because it is in form A over B or fraction. But we can change by using your calculator into whole number or natural or integer. 24 over 3, it will be equals 8. The same, -15 over -5, it will be equal +3. 0 over 5, it will be equal 0. So all of them is rational number, and we can change into natural and integer number. But there are some rational number we can't change into integer numbers. Like that, 3 over 4, 5 over 7, 35 over 10, all of them is rational number, but we can't change them into integer or natural number. All of them are rational, but we can't change into integer. So we know that how to change or when we can change the rational number into integer number when the numerator is divisible by denominator. In this case, we can change any rational number into integer or natural number. Let's see more exercise of this lesson. Exercise number 1, complete. He gave me here, number 1, the number 3 over x minus 2 is rational number if x not equals 1. Okay, how to solve this exercise? When he says this number is rational number, we must look here to the denominator. I means x minus 2. And try to find the suitable number here and replace it by x to make this denominator equal 0, and then we accepted it. Again, we try to find the suitable number here which makes this denominator equal 0, and then accept this number. What about the number which make here the denominator equal 0? Because we have here negative 2, so we replace x here by positive 2. Because 2 minus 2 equals 0, and if the denominator equals 0 here, that it means this isn't rational number, but we say this is rational number. So x here must be not equal positive 2. Let's see more exercise. Follows a set of rational numbers. The number here, x plus 3 over x minus 5 is rational number if x not equals what? Yes, we must also look to the denominator. Because we have here negative 5, we must replace x here by positive 5 to get 0 and accepted this number. So the final answer here it will be 5. Number 3. The number x minus 3 over x is rational number if x not equals what? Because we have here in denominator only x, so we accepted x equal 0 here. X not equal 0 here in this case. Number 4. The number x minus 4 over x plus 7 is not rational number if x equals what? We note here he say isn't rational number, but he or here also cancel not equal and replace it by equal sign. So both of them are the same. We must also here look to the denominator and try to find the suitable answer here. Here we have positive 7, so we replace x here by negative 7 to get 0 and accepted negative 7. So x here must equal negative 7. Number 5. This is different because he says the number x plus 3 over x minus 2 equals 0. In this case, if he says this rational number equals 0, we must look up to the numerator, not to the denominator. Because to find the answer here equals 0, we must have the numerator equal 0. So in this exercise, we must look up and put x here equals what to get 0 in the numerator. It will be x here equal negative 3. Number 6. The same equals 0, so we must look to the numerator. So it will be equal 0. I means here we must put x equal 0 because here 3x it means 3 times x. Number 7. The number absolute x minus 3 over x plus 6 equals 0. Here we must look to the numerator, but we know here there are absolute value. So x here has 2 values. Why? Because when we put absolute, it may be equals 3 or negative 3 to get a 0. Because if we have positive 3, it will be 3 minus 3 equals 0. If we have negative 3, it will be changed to be positive 3 minus 3 equal also 0. So x here must be equal to value 3 or negative 3. Finally, exercise number 2, write the following in form A over B. I means we change all the following numbers or following rational numbers into form A over B, I means fraction. The first one, it's so easy, 0.75 by using calculator, it will be equal 3 over 4. 1 and 2 over 5, it's so easy by using your calculator or your mind. We multiply 1 by 5 equals 5, plus 2 equals 7 over 5. But what about this decimal, and what about the meaning of this dot? That it means recurring decimal. How to write it by using calculator? It means 0.3 only? No, that it means 0.3333 more times, and when we see the sign arrow, press equal. It will be equals 1 over 3. Okay, there are difference between 0.3 and 0.3 dot. And the same 0.57. Both of them raised to 2 dots. It means 0.57, 57, 57, 57 more times. And when we see the arrow, press equal to find the suitable rational number. It will be equal 19 over 33. And what about 0.1.23 dot? It means we repeated the 3 digits, not only 1 and 3, but here we must repeat all of these digits. It means 0.123, 123, 123, and when we see the sign arrow, press equal, it will be equal 41 over 333. Finally, 30% by using your calculator, it means 3 over 10. Thanks for your listening, and goodbye in the next session with Mr. Hazim.